Hello, my name is Min Shu and this is my assignment 1 for the course of EH2745. I will introduce some basic principles of my codes. At first, I import some required libraries and then I just define some useful classes to represent different electrical components that we that are required to plot the grid. Just take the AC line segment as an example. Here I define the class of AC line segment and use these different values to represent the attributes of the AC line segment. And the attribute of equipment container ID is very important because it will be used to determine the different connecting relationship between these electrical components. And the AC line segments are AC line segment X, AC line segment BCH, the length, even the AC line segment GCH will be used to plot the grid. And in all these classes, I added the one special attribute as type. It will be used to extract the required information of these elements from the data structure that we will structure. Besides, when defining the class of terminal, I add one method which is used to add those connecting equipments that's connected to the certain terminal. And here, this attribute type will be used to represent different types of the conducting equipment. It will be used to find the correct connecting relationship between different components. Then here I create some empty lists to store the required information of different components. Here I pass the XM files, and from this and all the following parts are used to find the attributes of the class, namely the different electrical components. This part is used to find the information of base voltage. This part is used to find the information of substation, the voltage level, and the generating unit. And as for some electrical components such as synchronous machine, since its practical operating state should be different when taken different conditions into consideration, then we should find the practical values from the SH file instead of using those nominal values from the EQ files. More importantly, the state should be added to the correct machine. Then I just use the attribute of voltage ID to match the state with certain machine. Similarly, I also find the practical information of regulating control from the SH file and find the information of this class. And this part is used to find information of power transformer, and this part is used to find information of power transformer end, since each power transformer end should belongs to the certain transformer. Then I just use the attribute of power transformer ID to match different transformer ends to the correct power transformer, and then I added all the power transformer ends to the power transformer. This part is used to find information of loads, and it is also the same to match the state with the correct load. And this part is used to find the information of breaker, and this part is used to find information of ratio tap changer, and this part is used to find information of AC line segment. And this part is used to find the information of shunt compensators, and it is also very important to collect the practical information of the shunt compensators, because when we want to plot the grade, some information are required, some important information is required, such as the BP, B per section, G per section, and even the number of section. And we should calculate the practical values of the power, the active and reactive power, instead of use those nominal values. And this part, the following part, is used to determine the topology of the grid. And first, I just find all the nodes, and then I find all the terminals connected to the certain node, and then I find all the conducting equipments, including the bus bar, the power transformer, the breakers, the synchronous machines, the shunt compensators, the consumer loads, and AC line segments belongs to the certain terminal. After that, we can structure a very detailed data structure of the grid, and we can look at the variable of the grid. First, we can find that the grid contains 14 connectivity nodes, and the first 5 nodes represent the bus, and from the 6th connectivity node, it represents node instead of bus. Here, the first node should be the BE bus bar 1, and its terminal list including 3 terminals. The second terminal should be the breaker, the first terminal should be the bus bar, and the third terminal should be a shunt compensator. And in different terminals, there are some very important attributes such as conducting equipment ID, the connectivity node ID, the name, the terminal ID, and the type. And the attribute of type is very important when I try to determine the detailed connecting relationship between different components. And we can look at the conducting equipment list, since terminal 2 connected to a breakers, and this breaker, and we can find much more detailed information by collecting the conducting equipment list, and we can find the detailed attributes of this breaker, such as the base voltage, the ID of the breaker, the switch state, and this attribute is also very important when we want to plot the grid, because if it is open, then the line is disconnected. And we can also look at the node, and it also has a terminal list, and it should be connected to a power transformer, and also we can find some detailed information of this transformer. And this transformer is BETR21. And in the class of transformer, there is an attribute of windings list, and we can find the two end windings belong to this transformer. There are different detailed information of these two end windings. And this is the data structure of the grid. After finding it, we can extract the information of different elements from it. And first, I extract the bus information. Here, the type string B represents the bus, and the type string N represents the node. And then I extract transformer information. Here, it should be much more complicated than the codes of finding the bus information, since we should determine the higher voltage side and the lower voltage side. I just use this part to find the different values of the voltage of different sides, and then I just compare the value of two sides, and the higher ones should be the higher voltage side should be the bus HV, and the lower voltage side should be bus LV. And then I create the transformer model of the grid. This part is used to extract line information from the data structure. It should be similar to the following two parts. And here, we should determine the from bus and to bus of a line. And since the sequence of two attributes is not important, I just use the first variable as the from bus and the second variable of to bus. And as for the breaker, it is also very similar. And here, since different working state of a breaker can influence the topology of the grid, so I just use this part to find the different switch state. If the switch state of the breaker is false, which means the breaker is closed, then the line is not disconnected from other parts. If not, the breaker is opened, which means that the line is disconnected from other parts. And here I used this part to find the generator information. And since I found those practical information from the SH file, I just use them instead of those nominal values. And this part is used to find the information of the shunt compensators. And here I calculate the practical active and reactive power by using the practical data from the SH file. Since the variable B per section represents one electrical value of the shunt compensator, then I just calculate the active and reactive power by multiplying the B per section with the number of sections and the voltage. This part is used to find information of the load, and here I also use the practical data from the SH file. And finally, I plot the power grid. This is the power grid. This is the topology of the power grid. And we can find that there are 14 nodes and 3 power transformers. Yeah, 14 bus bar and 3 transformers, 2 lines, and 3 loads. And we have 9 breakers. And in the panel power, I just used the switch to represent the breakers. And this is my assignment 1, and thank you.